Hello, doctor. My name is Hardik Pradhapan from COA Section 2. Today I'm going to present a project, our final project. And first I'm going to present and followed by Tanir Malay and lastly Nathan will present. So first of all, we have our data points over here. We have enter message, choose complement message, is try again or and error. These are we're going to later on use in our program. And this input hex is our variable to hold our hex value. This is to hold the length of the hex value, and this is to hold whether we have the carry bit or not. And this condition is to allow looping. So whether the user wants to try again, like other values or not. So first of all, actually we have a top label to return back to the loop, and this whole section is to input the hex character. So the user will input the character into the input hex variable, and so after we have done that, we will get a display choose complement message. So it will be like choose your choose complement conversion. It will take back the input hex and output it so that the user know what hex value is being translated into choose complement. So over here we basically setting ECI to input hex, so the first value, and ECX to the ECX as initialization for the counter, using 3 because we need to start from the rightmost bit. So so in the begin function we so in the begin function we now what we're going to do is we're going to take the rightmost bit from the right, starting from the right, and we're going to move it to AL, our AL register. And what we are doing here is we are checking whether the value is less than A or not. So that's what we're doing over here, because if it's less than A, we automatically know that it's a number. It cannot be a digit, I mean an alphabet, so we straight away jump to A. So in A, basically what we do is we compare AL again, which has our hex digit, and we compare and we check whether it is between 0 and 5 or not. So if in the case where it is within the constraints, we do this line of codes, which first subtracts AL from AL and 0, and then subtracts that value from F, and then so this is the process we use to convert our hex values to our ones complement. So basically we split this part into 3 different sections, A, B, and C. So you can see here 0 to 5 will be executed here. So if that's false, we again we jump above, we jump to B, and over here we check whether it's 6 to 9 or not. So the same concept is being used as we used for A, but over here we are subtracting from, we're checking whether it's between 6 and 9, and we subtract with 6 and 9 over here, and we jump to D. So in the event that it is not between 6 and 9, we can for a fact know that it should be between A and F. That's why C is here. So same concept, but we are just subtracting different variables like A and 5. So in the event that even this is out of range, which means that AL is not between A and F, then we automatically know that this is a wrong input, like OX, something like that, which is not within the hex range. So we can straight away go to E2, which is the error, which will give us the error. So otherwise, if these conditions are all good, we do jump to D, which is a bigger loop. So we do jump to D to continue the process, and which will be explained by Tanir Malay.
Good morning, Doctor. My name is Tanir Malay Udayappan, and I will be explaining from now on. So, thank you, Ertik, for finishing over there. Okay. So now at D, what I'm doing is I'm comparing the value of ECX with 3. So why am I doing this is to find out the rightmost bit. In case the values are not equal, so jump not equal to H. So I will jump to H. At H, I will compare the carry value with 0 because I want to determine whether there's a carry value or not. If the carry value and 0 is not equals, I will jump to E. In E, what I do is I'm comparing the BL register with the character 9. So the reason why I'm doing this is when I add one, I want to know whether there is a carry bit present or not. So in case if I 9 plus 1 equals to 10, but in this case 9 plus 1 is supposed to equals to A. A does not have a carry bit. So my carry, I will move carry equals to 0. So now moving on to F, the same concept. But when F I plus 1, right? I'm not supposed to get any other value. I'm supposed to get 0. 0 with a carry equals to 1. That's the reason why when I want to do 2's complement for a character F plus 1, I have to set my carry as 1. And G is my default. G is for the numbers other than F and 9. So for an example, maybe from numbers 1 to 8 and A to E. So all of these numbers, when I plus 1, they do not have a carry. So the carry is default to become 0. So the once these three conditions have been done, I will check. I will keep on repeating this loop to check whether my ECX equals to 3 or not. So in case it's equal, it will skip to the next one and it will terminate this DEFG loop. So now moving on, my friend Mason, he will continue explaining from I onwards.
Right. Hello, doctor. My name is Jayanesh Jairaj. Okay. From here onwards, I'll be talking from I up till E3. So thank you to Hirti and Tanimalai for explaining the rest. So once we went through all that hassle of converting it to a ones complement and a two's complement, we're gonna go to loop I, whereby we already got, okay, let's say because we started from our rightmost bit, we already converted it into a two's complement, and it's in BL right now. From BL, we're gonna store it back into the array we took it from initially. Okay, which is ECI plus ECX, which should be 0 plus 3 actually. So after that, we're going to decrement our ECX, which is if it's from 3, we're going to decrement it to 2, and so on. Then we're going to compare our ECX here with -1 because we're going to loop it like a few times. Once it is at when the ECX equals to -1, we're going to jump to E1 because we're going to terminate the loop and start printing out the output that we want basically. So because we have the remaining 3 more digits, if if it's not equal to -1, we're gonna start the loop again and we're gonna jump back to begin and convert the rest of the digits because we have more conversion to do. So now let's say we terminated the loop and we're gonna print the output in E1. We're gonna move the offset of input hex into EDX. We're gonna print out our hex into its complement. Then we're gonna jump to E3, whereby we're gonna ask our user whether they wanna try again with a different digit this time. So once the hex is printed into complement, we're gonna ask our user whether they wanna continue or not. So now or it's either E1 or an E2, whereby we're gonna print out an error message whereby there'll be an invalid input in the hex number we keyed in initially, like maybe the alphabet 0, X, and etc., which will not be accepted by our system. So it's going to print an error message telling us that there's an error in the input we keyed in. And we're still going to jump to E3, whereby we're going to ask the user to try again to key in a different value or even just exit the whole system. So now in E3, like what I said, we're going to ask the user, we're going to print a try message and ask the user whether they want to try with a different input this time or they want to exit the whole system straight. So we're going to ask them a simple yes or no question. If yes, then we're going to jump to the top, whereby the user key in a new input and the whole conversion process begins again. Yeah, exactly, from top. Then we're going to begin from A all the way to E3 all over again, the whole process, if the user keys in Y, which is yes. If it's a no, we're straight going to exit the loop, and that's it. It stops right there. So yes, that's how we're going to end the code.